Hello and welcome to this video where I'm going to demonstrate how you can use smoothing with the XLMiner and the cloud. So this is obviously very similar to the approach you would do in a computer PC based XLMiner. But anyway, there's some changes, some additions you need to kind of consider while using the cloud-based system. So once again, I have opened the analytics solver on my browser. Please make sure that you're using either the Chrome or the Firefox browser to run your analysis. Please try not to use your Safari or any other browser on your Mac to run these things. And if you use the solver home to upload a file, make sure that your extension of the file is XLSX file. Okay, XLSX file. So this is a file. We have 160 observations. So what I will do is I will partition the file with 12 values as the validation period and 147 observations as my training period, and then I will demonstrate different smoothing methods on this particular partition. So to partition our data set, I will go to data mining, and then within that I will select partitioning. We have been partitioning with 12 values as validation because in Amtrak data, the assumption and the goal was to predict the next 12 observations. And therefore the forecasting goal was 12. And now, given this is has seasonality, the with monthly seasonality, our seasonality is also 12. So that's why we are going to select 12 as our validation period size, and the rest as my training period size. Now, given that I have already used this file a couple of times, the program automatically knows that month has been the time variable and the ridership is the variable in the partition. Now, if it is not there, please move it to ridership under variables in the partition and time as month. And then you select specify number of records because you're specifying what the length of the training and validation will be, where the training length is 147 and validation is 12. Okay. And then as I told you, when you do this, it might take some time, depends upon the speed of the internet. Right now I'm working pretty late at night, and that's why it's pretty fast. If you're analyzing things during the daytime, there may be other students who are also accessing the server at the same time, and it might delay your process. Okay, now I have three partition in this particular example, and the reason is I have been using different partitions and same partition, same information, but with different videos, and that's the reason. Otherwise, you will only see one partition. So keep in mind, you will only see one partition if you do it for the first time. Okay. So after we're done with the partition, I'm going to now run different smoothing techniques. The first smoothing techniques we're going to learn, obviously I'll select this by going to on the time series, is our moving average. Okay, we'll run a moving average on this particular partition data set. Given that we'll try a moving average of 12 as we have obviously 12, seasonality as my 12. Okay, so I'll select moving average, and you will see a particular window coming up exactly as you may have seen in your standalone XLMiner. So the first thing we will do is we're going to select the partition data set. All the partitions are the same. Okay, keep in mind. So the ridership is the variable we want to forecast. So ridership should be under selected variable. Month is my time variable. Okay. Now So that is the variables we are going to consider. Now, the goal will be to run a moving average of 12, the window of 12. Okay. So what I will do is I will change the interval to 12, and then I will say produce forecast. Okay, produce forecast and validation, because we are trying to figure out what's the best method. And I click OK, and that's it. Okay, and that's we are done with our moving average on the cloud. Now once again, this is very similar to the running the stuff on the standalone program. Okay, oh yeah, the only thing is, the tab names are different. Okay, tab names are different. As you can see, it already gave you some plots. Some of the plots automatically comes from this. Sometimes it does not. Most cases, what I've seen is the plots. If you use smoothing techniques, any kind of smoothing techniques, ARIMA or anything, you do get plots. Okay, you will not get the plots directly from the when you run regression, but there may be other ways you can get those plots. Okay, I may not be aware of those. Anyway, so this is our data set plot. You can see the original data set and also the smoothing with windows of 12. If we scroll down, obviously our data set, you should be able to see, the MSC and all made everything. Okay, as we deal with it, we typically talk about the map of our validation period. So please make sure that you use that to use your analysis. Everything you need is typically particularly comes out under this moving average tab. Okay, so here's our first run using a moving average. Now the second what we'll do is we're going to now run a simple exponential model. Smoothing technique, I will select a simple exponential. I'll make sure that I am using obviously the partition data set. Okay. Here is our window. Our partition data set will be considered. So we'll use the worksheet one, TS partition. And then ridership obviously is our selected variable. Month is my time variable. And let's say we use an alpha of 0.2, say produce forecast on validation, and click OK. Okay. So once again, you will get all the values you typically get. And keep in mind, the tab will come up. Let's scroll down. The tab for the Excel simple exponential model. As you can see, simple exponential model is this. Okay, it has all the variables you need, typically the RMSCs and so on and so forth. Okay, so you will see the MAP RMSC for both training and validation. This is the training one. Okay, on the right hand, if you just scroll down, you will see the validation maps, and you can report those maps for your analysis. Okay, for these are your validation maps. So now the numbers should be very similar to what you will get if you run a standalone, an XLMiner on your computer. Okay, the numbers might change here and there. It depends upon the estimation process or the clock of your computer, but it's not a whole lot of difference. Okay, so keep in mind. The difference should be statistically insignificant. Anyway, so similarly, you can run obviously other approaches, very similar. You can go to smoothing, and then you select, let's say you select a Holz winters or a double exponential. Let me show you a Holz winters with additive seasonality, because this data set has an additive seasonality, not multiplicative, as you can see directly from the plots. And then you will get a similar window as you have already seen in other videos. You select our ridership as our selected variable, and then time as a month, and then period is 12, that is our seasonality in our data set. And then we'll keep the alpha beta gamma as it is. and let's say I say, produce forecast. I need 12 forecasts by observation. Okay, and I can say update is each time, depends upon my error level, which is pretty low if you remember from the other lectures, and you click OK. Okay, it might take some time once again to analyze, but once again, since I'm doing it, creating these videos at night, typically the internet speed is pretty high. I did have no trouble getting these things, and it might be obviously have trouble if you do it in a different time of the day. Anyway, as you can see, additive Holz Winters tab comes out. Here is our graph, pretty well done. I mean, very close to what you would have seen. Then we also have the MAPE. MAPE was 3.18 for the training. If we can go to the validation, you will also get the validation MAPE and everything. So, typically whatever you get directly from your analysis, and in a standalone, you're going to get the same thing using this particular method. Okay, so keep in mind. Okay, now in this case, looks like I did not, once again, I did not select the partition values, and that's why I don't see the errors of the validation period. Okay, so keep in mind, I think the key here is, keep in mind when you're running the methods, you are actually, so for example, smoothing technique, Holz Winters, additive, make sure that you are selecting a partition data set if it is not there. Okay, so partition data set is what you should consider. Okay, ridership as your selected variable, month as your time, period is 12, right? And then produce forecast and validation, and you click OK. Okay, and it should give you the map of the obviously validation and period and so. Now, once again, keep in mind, the key here is, if you don't see, a variable you should be looking for, don't panic. It should be there somewhere. Many times the challenge is, you may not be, may not have, you may not have selected the correct data set. For example, you may not have used the partition data for running a different models. So anyway, the point here is, if you do not see a particular value you're looking for, it must be there somewhere, unless you may have made mistake of selecting the wrong data set for running the models. Okay. Anyway, so this ends this particular video. In this particular video, I demonstrated how you can use a cloud-based XLMiner platform to run the smoothing techniques for forecasting. I demonstrated this with moving average, a simple exponential, and the additive Holz-Winters method. Okay, and it looks like it doesn't take a whole lot of time to run the models if you're doing it at night. However, you might get might be slow if you're running analysis in the daytime. Now, as we ran the different smoothing techniques, you do see that the graphs come out, but such graphs are typically not observed if you're running a regression. In regression, you need to download the file and obviously rerun or create the plots. For the smoothing techniques, the plots are automatically created by the program. Anyway, this ends this particular video. Thank you for watching it.